Our, ne our next speaker is Carlo Evia. Carlo, are you there? Carlos, are you there?
I'm here.
Super. Let me make a short introduction. You know, this is probably a non-typical speaker for a TUG conference. Carlos is a professor of communications at Virginia Tech, and where he's also an associate dean and a CTO for the College of Liberal Arts and Human Sciences. He started life as a DJ and evolved into a journalist and a writer for information technology. Academically, he's a professor of English and professional and technical writing and communications. He's probably one of the best persons to talk about this particular subject. And with that, I'll leave you to the second keynote speaker of this conference, Carlos Evia.
Thank you very much. Let me start the sharing of the screen, which, as we know, it can always go bad. So I hope that you can see my slideshow now. Let me know if it's looking good. Now, I really appreciate the invitation to give this keynote presentation. And let me tell you a bit about me. And Paolo just said some very nice things about me, but what do we need to know? My day job, indeed, I'm a professor of communication at Virginia Tech, and I have been in this job for about 18 years now. And I sold my soul to administration too, and I'm an associate dean of transdisciplinary initiatives and chief technology officer in the College of Liberal Arts and Human Sciences. My background is quite mixed because my undergraduate was in communication studies in a very theoretical Marxist small school. And then I fell in love with a computer and I got a master's in computer science. And then I decided that I wanted to combine both of those interests when I got my PhD, and I got a PhD in technical communication and rhetoric. If you ask me how would I define myself now, I think that the main thing that will come to mind, I'm a content operations specialist. And we can talk more about that if you want, but that's not why you came here. As I was preparing this keynote presentation, which has the title of The Future of Technical Documentation, starts with its recent past, I realized that a subtitle or even an alternative title for the presentation would be, "We owe something to a former IBMer." Or a more complimentary, "Damn, those IBMers were right." So we're going to be talking about some things that happened at IBM some years ago. Trust me, we're going to get to that in a few minutes. But first, let me talk about the official title of the presentation. When Boris contacted the leadership of the Association for Computing Machinery's Special Interest Group on Design of Communication, SIGDOC, he asked for recommendations on speakers to address the future of technical documentation, and that's how they came to me. I came to where I am because I was developing very bad software. I'm not developing any software anymore. I haven't programmed anything in ages. And I realized that the documentation was terrible, and I was very much interested in improving the ways in which we could write documentation for software. And I started doing that, and eventually it became my career. A comment about the recent past of technical documentation should address that group, the ACM SIGDOC, has changed its name. And it used to be the Special Interest Group for Documentation. Actually, it used to be the Special Interest Group on Systems Documentation from 1982 to 1996. And then it changed its name to Special Interest Group on Computer Documentation, and then just for documentation. But now they don't even call it documentation, and the DOC that used to be documentation now stands for Design of Communication. So that might tell you that documentation might not be such a popular thing anymore in the world of technical communication. But technical communication as the main umbrella that contains in this country and many other countries in the world. And when I say this country, I mean the United States of America. Technical communication continues to be the umbrella that absorbs and covers all of the processes behind the development and conveying technical information from experts to a non-technical audience, or a dreaded word that I really don't like, the lay people. You don't have a certain knowledge, we have the knowledge. We're gonna develop documentation that will guide you as you complete the steps required. Technical communication as a field, as a discipline in academia and in industry, is pretty much still concerned with technical documentation, but mainly as part of a universe of different genres of products that require that mediation between a user and an expert that really characterizes the job of a technical communicator. And here is where I'm going to go back to the recent past of technical communication. So 10 years ago, the Adobe Technical Communication Suite, that's a product of Adobe. You can buy it, and it includes FrameMaker and other tools that, like RoboHelp, that Adobe has been peddling to develop technical documentation for many years. About 10 years ago, they published to several social media channels this video that they titled "The Future of TechCom." And the video uses stop motion animation and fast draw techniques to summarize the features of Adobe's tools and services for technical communication. And here's a slide from that video, which is in YouTube, by the way. You can go take a look at it, I hope, after my talk and not right now. As a pair of rapidly animated hands is assembling Lego pieces, the video's narrator describes that for some people, the future of technical communication is all about more and more structured content and the ability to work faster and smarter with XML and data constructs. Trust me, we're going to go back to data. So if that doesn't sound familiar, that is at the core of this presentation. So approaching the end of the runtime of the video, which is about 2.5 minutes, the video claims that this is a very exciting future to be in. And at this point, we encounter the first IBMers of the presentation. As the main engine behind the future of technical communication that the video was talking about is DITA, which is the Darwin Information Typing Architecture. This should be interesting to the audience in this talk as tech users, because it involves a markup language. DITA is now an open standard for structuring and publishing technical information. Probably that sounds familiar, right? So DITA was, big surprise, developed by IBM in the late 1990s, and is very much alive as an open standard maintained by the nonprofit consortium of the OASIS, which stands for the Organization for the Advancement of Structured Information Standards. In an interview with the website DITA Writer, Don Day is the guy here to the left. The guy to the right is Michael Priestley, and he's going to come back later in the presentation. There were IBMers who developed this grammar of XML to structure technical documentation at IBM. So Don Day, in an interview a few years ago, was talking about the origins of DITA, and he chronicled those origins to experiments with XML that they were doing early in the 21st century or late 20th century. So he said something to the effect that with the advent of XML as the new markup standard in 1998, IBM decided that they wanted to have something very tightly structured that will keep all of their, particularly how-tos, all of the tasks that IBM had related to hardware and software with very similar components. So as IBM was acquiring back in the day smaller companies, if the companies had their how-tos and instructions and tutorials all unstructured, it was very difficult to acquire them and integrate them into the repositories that IBM was working with. But by making this an open standard and eventually turning it into a very popular standard in the world of technical documentation, IBM accomplished that those smaller companies were most likely using DITA and XML, And when they merged, when they acquired them, it was not a big problem to get them into using what IBM was already using with DITA. So DITA consists of a set of design principles for creating information type modules at a topic level and for using that content in delivery modes that can transform to online help, technical documentation, and product support portals on the web. The creators of DITA say that the acronym represented a great deal of messaging in a compact and memorable acronym that stands for, the D is Darwin, which tells you that in DITA, in XML, the document types that they establish in the standard can evolve from a base and accommodate to the needs of different teams. And we're going to talk more about that in a few minutes. The IT is information typing for the representation of knowledge as specially typed units. And I'm going to show you a few examples in a few minutes. And the A stands for architecture, which is a statement that this was not an absolute monolithic design, but an extensible tool that could support many uses. Like I said, IBM eventually donated DITA as an open standard, which is currently maintained by Oasis. And it has evolved substantially since that initial donation, and it's quite alive. And the technical committee in charge of maintaining the standard is working right now on developing a new version 2.0 of the DITA standard. The purpose of this technical committee maintaining the standard is to define and maintain DITA and to promote its use as the architecture of choice for creating information, standard information types and domain-specific vocabularies. That's from their website and their mission. And in that group contains a small army of former IBMers, including Chris Eberlein, Elliot Kimber, and Michael Priestley, that have kept the standard alive and evolving and very healthy, with some very good adoption and usage figures. That's where you need your abacus to count the usage figures. Now, if I ask you in this conference to give me exact numbers of worldwide users of tech or LaTeX or LaTeX, probably you will ignore me or call me mean names, because it's very difficult to tell me how many people actually use LaTeX. But, you know, we can find specific numbers about how many institutions are using Overleaf, or how many downloads we're getting of TechLive or MacTech. You can give me those specific numbers. And that also happens with DITA as an open standard. There are no specific numbers that can tell you exactly how many companies or how many people in the world use DITA to structure their technical documentation. All I can say is that it's quite popular, and in the specific community of technical communication and technical documentation, it has been very popular for the past 20 years. So just like in LaTeX, we declare a document class to start a file. In DITA, we can use different topic types with specific semantic elements that structure and then later allow us to publish technical information. The literature concentrates on three main topic types that represent the vast majority of content that is produced to support technical documentation. And these are concept, task, and reference. So if you have ever played with DITA or a similar standard for structuring technical information, you have seen concept, task, and reference. The concept topic type provides background information that, you know, explains what is this. It doesn't have steps. Think of it as if you were writing a software guide for a package that you're developing, or a package that you're using and doesn't have good documentation and you want to improve that. A concept will be probably part of an introduction to your documentation that said, well, this is the documentation for package X, and the purpose of this documentation is this, and that. It will explain that. It will provide the introductory content, but it will not necessarily give the users at this point the how-to information that they need, because that happens in the task. The task information type in data is specifically addressing how-to questions. How do I do something? And that one includes precise structures, very semantic structures for steps, commands, sub-steps, informations, warning, and alerts that really guide the user as they perform something, and they can recover from errors if that's the case. So think of the task information type in data as what shapes instructions, what shapes procedures, or even a recipe if you were assembling a cookbook or something like that. So for authors of technical documentation, these foundational topic types provide constraints and structures beyond the basic presentation-oriented templates that you could achieve with, say, HTML. In data, authors can create consistent topics to assemble collections of information with elements that can be reused even at the phrase level. By giving a semantic tag surrounding a specific phrase or a specific word, I can reuse that content in other topics, and that saves me the time and the pain of writing something many, many times. For example, a concept could be an introduction to a particular software package, like I mentioned, while a task or a collection of tasks can provide instructions on how to install and how to use the package. And a reference topic can list common extensions and tools associated with the package. Reference is the third one in that group of concept, task, and reference information types that really define data as it comes to support technical documentation. And reference mainly gives you a list of properties for a command or properties for an item that you really want to explain without giving steps on how to use that, because those go obviously in the task. So in very practical terms, data's topic types include XML tags for content moves or strategies, such as a short description that explains what is the purpose of a specific topic, steps, and examples, which are frequently used in technical publications. Pure XML does not provide a set of defined tags. As you know, if you start the document in XML, you can create whatever tags you want. Instead of doing that, data comes with a set number of elements that you can use. And those are obviously tags that have been proven over decades to be helpful for technical communicators. So here's an example in code of what a basic, very basic topic in data looks like. And as you know, the first line is the XML declaration. And then we have the special doc type declaration that connects to conforming with the DTD that will tell you that this is a data task. The parent element of task has a unique ID. Then we have other children elements that provide a title for this task. They give me a short description, and then the body of the task contains steps. And every step contains a command, which is the heart of that how-to. And then we can have information in each one of our steps. And this keeps things quite neatly contained and structured. And I will show you later what are some of the main features that structured information to this level enable for technical communicators. An advantage of data, and that's where the D of data comes, is that one of the main selling points of data, and it's funny that I say that it's selling because it's an open standard and it doesn't cost money, is that the promise that you can customize tasks for specific situations, that even if you customize them, we'll still keep it relevant and complying with the standard. That means that if, for example, if company X, software company, decides that the basic structure for a task is good enough, but they want to customize the tags, they can do that. And instead of title, they can say it company X title, and company X title becomes the name of that specific XML element. And that will still make it relevant for the standard. You can then change things and modify and adapt them by playing with the XSLT files that transform this. Funny enough, one of the things that this enables is that you can have multi-channel or omni-channel publication in data. You have many open source and commercial tools that take data structured content and allow you to build websites, allow you to build PDFs, and allow you to even communicate with APIs and do more sophisticated things. Nobody should be surprised that some of those actually are based on LaTeX, and specifically when it comes to academic and scientific publication. So that is what is at the core of that recent past of technical documentation: workflows and tools based on data or something similar to data. This became mainstream in the past 2 decades and has enabled practices such as single sourcing, modularity, and multi-channel or omni-channel publishing. Let me show you a few of those things. So this is a graph that I have been using for many years. To be honest with you, I don't even know where it came from, so I apologize if somebody owns the copyright of this, but most likely they're going to be colleagues of mine who have worked in the development of the data standard, so they will not be offended by that. The concept of single sourcing means that a team can have a common repository of topics or even element types. So let's say a common legal disclaimer that appears in a paragraph in many of those topics. And by referencing that file or that specific paragraph or sentence or word in a document, every file that is connected or linked to that one will be automatically updated if I make a change in the source. And of course, this is much better than copy and paste, and we can achieve some of these things with tech. And one of the advantages is that, as you can see here, I have my central XML repository of topics. And then by connecting it to a data publishing engine, I can assemble my documentation on the fly. And I don't have to write specifically thinking I have to make a book, and that's the only deliverable that I can have. You can use that same content without copying and pasting it by clicking on a button or entering one sentence in your command line prompt. You can assemble a book, you can assemble a PDF, you can assemble a website, or you can even communicate your information to an API for more sophisticated omni-channel publishing. Another advantage of data is the concept of modularity. Nothing new for tech users here, but when you're authoring a document or a series of documents in data, your whole document doesn't have to be written like a complete chapter. It can be assembled from little pieces up to the level of a word or a sentence that are reused and linked elsewhere in the documentation. So this aggregation process in data happens with the mechanism of a data map, which is an XML document that has a collection of hyperreferences linking those components in the sequence, in the hierarchy in which you're going to need them. And another main feature of data and data-like publishing methodologies are the ideas of multi and omni-channel publishing. It's like DVI on steroids. Multi-channel allows you to publish, like I mentioned, out of the box. Just any open source implementation of data will allow you to publish to PDF, HTML, Markdown, Eclipse help, and HTML help. And commercial applications of data will take it even further, and you can really customize the things that you build and you create. In a similar way to the tech community, the user community of data has also contributed open source plugins that enable publishing to many other formats. Omni-channel publishing is even more interesting, and it enables content as a service approaches that serve data topics or components through APIs. So if you remember RSS feeds, With XML, this is like a more advanced version of that. DITA is particularly good at that because of the semantic value that its XML tags and attributes can provide as metadata for filtering and customization of those deliverables. So that's the recent past. And now we get to the present. Where are we now? And in the previous talk, Peter K.G. Williams was talking about how Markdown has become the thing that people want to use. And when you introduce something that looks verbose, many developers are going to be giving you the stink eye, and they don't want to do anything like that because they want lightweight, they want simple programming languages, and they want their documentation to reflect that. I could talk about adoption numbers, like I said, and success stories about data, but that cannot hide the fact that the evolution of technical documentation takes place on kind of a rocky path. Even in hardcore technical communication circles, there has been pushback and criticism against XML and its relationship with technical communication. People say that it's bulky, and blogs and social media exchanges question the status of XML and DITA as the main markup languages behind technical communication and technical documentation products. While, you know, some of the critics might acknowledge that DITA is effective for the development of big user manuals in complex industries, in highly regulated industries, some are concerned that not everything might need this. And if you're just writing basic documentation for a plugin, for example, it might be overkill to do a lot of XML tags if your content is not going to be reused in other applications. Others argue, like I mentioned, that, you know, verbose computing languages are becoming obsolete, but, you know, the kind of filtering, the kind of processing that the deep semantics of DITA and XML enable are something that we should not ignore. So those concerns are valid, and we, and I say we because I've been involved with this, even if I'm not a former IBMer. We listened to those concerns, and that's why another IBMer came to the rescue, and Michael Priestley, one of the key architects of DITA back in the late 1990s, started talking about developing a way to connect XML, particularly DITA, with more lightweight approaches. And so lightweight DITA was born. As a disclaimer, I was involved in the development of lightweight DITA, and I worked closely with Michael Priestley for many years. Although I'm not an active member of OASIS and the DITA technical committee anymore, I'm still a DITA and lightweight DITA evangelist. Of course, see this keynote presentation as an example. So the way that we define lightweight DITA is similar to DITA, is a topic-based architecture for tagging and structuring intelligent content using flexible markup options. Lightweight DITA aims to streamline the DITA authoring experience by presenting three formats for content creation. We have XDITA, and XDITA is an XML-based format with a subset of all of the DITA elements. And if in DITA you have, gosh, I don't even know how many tags you have in the DITA standard, but probably you have hundreds of those. In XDITA, you only have like 20 of those. And that allows you to create simple, but still powerful structured documents that can be marked up even to the word or sentence level for filtering, for transclusion, for customizing deliverables to different types of users and different types of needs. The second flavor of lightweight DITA is HDITA. It's a format that represents basic DITA-like structures in HTML5 that can be used to author content and publish content, but is mainly used as an in-between for people who want to build tools that are not fully depending on XML, but can use HTML. You can do basic and advanced structures that allow you to structure a topic or a paragraph, a sentence, a word, and combine those with existing publishing chains behind data. And the last one is mdata, which is a markdown format, which is a subset of data elements that can be used to maximize input readability while maintaining a component of structure in your content. And these three flavors of lightweight data are compatible with each other. You can mix and match X data with H data and M data, and you don't need to adopt the three of them to say that, hey, I'm using lightweight data. You can author something in M data and you still will be using lightweight data. All of the three formats of lightweight data are compatible with each other and also with full data XML. So for a team of authors with diverse technical backgrounds and communication skills, the different formats of lightweight data allow collaboration and content exchange in a centralized solution. For example, a software company can have a technical writer that creates instructions in X data, which is based on XML, while a marketing professional writes a description of the app's features in HTML, in H data. And an engineer uses mdata, which is based in Markdown, to create basic API reference topics. All of those topics, whenever you put them in a data or lightweight data friendly processor, either an open source one, like the Data Open Toolkit, or a more sophisticated commercial application, are going to be treated like data and will benefit from the same single sourcing, modularity, and multi-channel and omni-channel capabilities that data can achieve. So now, let me tell you that indeed some worry that going too lightweight is not going to help. And some people, like, in the previous session, complained that Markdown and very lightweight approaches are privileging engineering convenience over content production efficiencies. And that might not be the best way forward. And here's where we encounter yet another former IBMer who recently came out to warn users about the perils of going too lightweight. Michael Iantosca, who was with IBM, wrote a blog post talking about if you really embrace Markdown and restructure text, which is another lightweight authoring format that has become popular with developers and some technical authors. Iantosca claims that you're going to lose that level of granularity and flexibility that data enables for people to really have robust sets of content topics that can be filtered, that can be in automated production lines. And we will lose that if we go entirely too lightweight. And those are some of the things that data is very good at. But this requires that we go back to the recent past of technical documentation so we can create content that will allow us to give things to human beings, but also play nicely with robots and, do behind the scenes computation with our content and not have just our content like static chunks of text, which is something that we in technical communication have conquered 20 years ago. We were like, no, the chunk of text is your worst enemy because you cannot compute it, you cannot filter it, you cannot treat it like something that will benefit different users at the same time. So we don't want to go back to that. We want to probably go back to the recent past when we were talking about the future is XML, the future is data. And that's what I think, in my opinion, that we need to go. We need to make a combination of finding paths, making bridges that connect, let's be honest, the very verbose, the very heavy structures of XML with more lightweight approaches. And here's what I can tell you. What does that mean for the tech community? Markdown is your friend. I know that some people don't like Markdown, but if you embrace to a degree the Markdown package, you can share content that is written in lightweight data and use it in some of your tech publishing pipelines. And also that same content can be used in data in lightweight data publishing pipelines. And if you're not very familiar with the Markdown package, I mean, there's a session tomorrow with Teresa Bravtova that is a gentle introduction to Markdown for writers. And I strongly suggest that you go there, because that's honestly where I see that things are going to develop these complex networks of sharing information, because there is a use case for everything. There will be a use case for very lightweight markup languages. There will be a use case for very complex markup languages like full data XML. So I really appreciate that, and I hope that we have time for some questions, Paul.
Well, I open the floor, and if you have any questions for Carlos, please unmute yourself and bring it over. It's nice to spend some time to think about those questions, Carlos, because when we write documentation, it's almost an ad hoc. It's almost the last step you do, and not very much thought is put into it as we go along. Developers have a special way to deal with that particular issue, and it's nice to bring this to the forefront rather than an ad hoc.
And one of the frustrating things is that I have seen many applications, recent applications, that in which developers are using JSON strings to put the content, and they have a combination of rules for presentation. They have like CSS built in a JSON string. And in technical communication, we've been fighting for 20 years for that separation. We were saying, don't mix CSS and content in the same document, because that way you can take that same content and with a click, publish it to a PDF, to an API, to a website, to an app. And some who don't want to get involved with very bulky languages like XML, I don't blame them, are repeating those mistakes. And we're like, we've been there, and that's not the way to go. But we want to build bridges, and we want to have ways in which people can contribute, even using very lightweight markup languages like Markdown.
Right. Jonathan Fine, please join us.
Well, thank you very much for your talk, Carlos. It's very, very interesting. And I'm going to ask a question related to the previous talk from Peter Williams, who mentioned Evia, which had a sort of quadrant, which reminded me, and your talk reminded me of the triple you had of, I think, tasks and reference and the third one. So I wondered if you'd come across the Evia quadrant. I came across it because I know its promoter, Daniel Procida, who works in Canonical, and I went to a training workshop he did on that for research software engineers. I think it's interestingly complementary to what you're talking about, because he is talking about the, can I use it, the creative art of technical documentation, what you think about, what you feel when you go about the task, rather than the technical side of it, which is, if you want, the tags and markups. And if you're willing to, I'm also reminded that in olden days, there was something called copy editing that publishers used to do. That helps bring about a uniformity of style, for example, in an encyclopedia. So I wonder if you'd like to make some comments on both of those, or any of those.
Yeah, one of the, like I mentioned, one of the key features of data is that the Darwin side of things, that those core topics can evolve and can become something different. So out of the box, you can use concept, task, reference, and topic as the structures that, if they work for you, you can do that. But you can customize and change them. For example, we have used our own specialization for comic strips, because we had a project developing comic strips that had embedded how-to content. And the opening tag, instead of being a task, was strip. And each panel of the comic strip had its own little XML representation. And that allowed us to put the place where the image was going to be and even coordinates for where it was going to be separated from the content, because the specific how-to was being referenced from the instructions, which were in a completely different task topic. And this was still valid data because it was a specialization from the standard. So that's one of the things that I really see as a key feature of data, that you can create your own. Again, you will have to work with XSLT, which is not the sexiest thing in the world, but that gives you the flexibility of creating your own information types to incorporate a combination of that technical content with more artistic representations of how you want to present it. So that's the main thing. And talking about more advanced publishing situations and copy editing, I'm going to let Dave Blakesley talk about that tomorrow in his keynote presentation. As a colleague of mine from the same background of technical communication, because he's one of the kings of publishing in our field. So maybe he can give us some insights about that. And he will be ready. That's what he said.
Yes, yes, yes. Well, without delay, thank you very much for the wonderful talk, Carlos.
Thank you very much.
Yeah.